Good morning, guys. Again, back. This is Rahul Mohare, Assistant Professor from Department of Management Technology. I again welcome you to a 5-day FDP program on Advanced Research Methodology. We are learning the different MCDM techniques. Till now, we might have learned 6 different MCDM techniques. Today, we are going to learn a technique that is called as GRA relational analysis. The technique wherein Professor Zavadkar might have not given any kind of contribution. This is based on GRA theory. So what exactly the GRA theory is? GRA theory is an effective uncertainty knowledge acquisition model. Once here we cannot give a proportionate weight to each criteria. So why? It is an effective uncertainty knowledge acquisition model. It was proposed by Professor Deng from China. It mainly focuses on small sample and limited information, which is only known partially. GRA theory is an essential uncertain knowledge acquisition method for small sample, poor information. The classic GRA theory does not adequately take into account the distribution of dataset and lacks the effective method to analyze and mine big sample in multigranularity. Once if you have many different situations with you wherein the data have where the alternatives have many different categories across different platform, then how to analyze the things by assigning the weight. So this can be abolished by using this method. Means and we being researcher, we are very fond of normal distribution. So in the view of universality of normal distribution, the normality GRA number is proposed. Then the corresponding definition and calculation method of the relational degree between normality GRA numbers are constructed. We'll see how to construct it by using the method which is proposed here, and by using the GRA algorithm. On the basis of GRA relational analytical method in multigranularity is put forward to realize the automatic clustering in the specified granularity without any experience or knowledge. There are many different GRA relational method or GRA method. They are GRA relational analysis, the one which we are going to learn today. The GRA clustering, GRA statistic is there, operational research, system control, system modeling, system forecast. So all these comes under the GRA relational analysis. GRA relational analysis is an important task of GRA theory by which we can scale the similar or different level of development traits among various factors. It has drawn more and more researchers' attention in recent years and achieved many good results. GRA relational analysis is a method for quantitatively describing and comparing to the development tendency of the system. The main idea is to compare the geometrical similarity between reference data sequence and several comparative data sequences. The higher the GRA correlation, the closer these sequences about their development direction and the rate, and the relationship will be closer to each other. Now this method proposes theoretically a dependence to measure the correlation degree of factors. By virtue of this method, it means that the more similarity, the more factor correlation. GRA analysis or GRA relational analysis uses GRA relational grade. In the previous methods, we might have used different techniques, maybe the utility value, maybe the preference value, maybe the correlational grade. But here in GRA, what we are having the GRA relational grade, by virtue of which we are going to assign the rank to each alternative. So what does this GRA relational grade do? The GRA relational grade, we use it to measure relation degree of factor. In this respect, GRA relational theory provides efficiently management of uncertainty. Now, how we are going to do it? We are having different steps for GRA. Firstly, all alternatives are transformed to a comparability sequence in a Gray relational analysis. This transformation is called as Gray relational generating. In this step, the data are normalized and transformed to values in 0 and 1 interval. Considering the sequence, a reference ideal target sequence is defined, then the Gray relational coefficient is calculated between reference sequence and all comparability sequences. And then finally, Gray relational grade between reference sequence and comparability sequence is calculated. According to Gray relational coefficient, the highest Gray relational grade among the alternatives will be the choice. There are certain problems which are associated with this GRA, the Gray relational analysis method, means which are notified by eminent researcher. If you will go through the papers, different papers, you will come to know that these are the problems which have been discussed in many different research papers. The very first problem is that this Gray modeling assumes that data is exponential and must be explained further. So while converting the data, we convert the data into the exponential manner. Second problem is the data pre-processing seems it could be potentially problematic since information is inevitably being lost. Whenever we are doing this conversion for calculation of Gray relational grade, we are losing some kind of inevitability, and that is the another problem in the Gray relational analysis. And lastly, the Gray relational theory does not have a solid mathematical foundation like probability theory, fuzzy theory, and many other theories. So these are the major issues that need to be addressed while doing the Gray analysis. Now, one thing which should be noted is that this is the only method that we have learned so far. Means among all the methods that we have learned so far, this is the method, or this will be a method which is not going to use the weights. Till now, for every method we had the weight matrix, but this particular method will not have the weight matrix. This is the major difference. Means if we want to locate or identify the major differences in all the MCDM techniques that we have learned so far, so this is the very first difference, that this particular method does not have the weight matrix. So if it does not have the weight matrix, how we are going to deal with that? We are going to calculate the deviation from the normalized matrix. Now how we are going to calculate the deviation, we'll see in short while when we are going to do it into Excel. Then means the step will be that normalize the original matrix, then calculation of Gray relational coefficient, then calculation of Gray relational grade, and then ranking of Gray relational grade. So this is the notified thing for us that it is a decision matrix, M by N matrix, where M alternatives and N criterias are there. Step 2 will be the normalization of decision matrix. Then how we are going to normalize the decision matrix? So if we are having the cost criteria, then for the cost criteria value or the normalization method will be like this, that maximum from each column should be considered and each value should be subtracted from that maximum value, and the denominator will remain same, that maximum value minus minimum value from the respective criteria column. This will be for the benefit criteria, and for the cost criteria it will be that from each value we are going to subtract the minimum value and the denominator will remain same, that is maximum value minus minimum value. So this is the step how we are going to normalize the given matrix. First step is that having the decision matrix, and second step will be to normalize the matrix. Step 4 will be the calculation of Gray relational coefficient, and step 5 will be the calculation of Gray relational grade. Now in step 4, how we are going to calculate the Gray relational coefficient? The Gray relational coefficient will be calculated as minimum value, the difference of minimum value plus difference of maximum value upon current value plus maximum value. So let us see that and let us go to Excel, and we have that own problem with us. Then how we are going to deal with this problem? The very first step will be to calculate the normalization matrix. Then we will be calculating the deviation sequence. Then we will be calculating GRA reduction coefficient, and then we are going to calculate Gray relational coefficient of Gray relation. So this is the method, or this is the thing that we are going to apply. So normalization matrix. Just now what we have discussed, if it is a cost criteria, how we are going to have the cost criteria? In the cost criteria, we are supposed to have this thing, that maximum value need to find out, and we need to subtract each value from this maximum value, and the denominator will be that maximum value minus minimum value. So let us go to Excel and let us do it. Since we are having the cost criteria, we are very aware about it now, that the cells which are indicated in green color belongs to cost criteria, and those which are into pink color belongs to the benefit criteria. So let us normalize this matrix by using the GRA technique. The first thing is to uh, make the normalization of the cost criteria. So the numerator is that maximum value need to be found out. So let us find out maximum value, maximum of all these values. So we have selected this value. Since we need to drag it horizontally as well as vertically, we will press F4 twice. So we got a maximum value minus each value of the respective column. So we have selected this. Now we will close the bracket. If you will see here, we have obtained the numerator. So numerator is obtained. Now we need to divide it by the other thing. Now what that other thing is? That other thing is the maximum value into the maximum value minus the minimum value. Maximum value from the respective column minus minimum value from the respective column. So here let us put a bracket. Maximum value, since we need to drag it horizontally and vertically, press F4 twice, minus minimum from the same column, so here we complete the formula. While typing the Excel formula, you just need to remember 2-3 things, that if you are not using the bracket, means if we have not used the bracket, it might divide all these things and then subtract this value. So try to close the bracket well, try to use the brackets well, try to freeze the cells well, so that you can avoid the mistakes which can be occurred, or which will be occurring while dragging the formula into another cell. So we just make an enter. We first drag it horizontally and then drag vertically. So in normalization matrix, or you might have seen that every matrix starting from this normalization matrix ahead, we will be having all the values which are into a uniform scale of 0 to 1. Means nothing falls beyond 0 and nothing goes more than 1. So this is a normalization matrix. So we have got this value, we have got this value. If you want to check this value, just look at this formula bar. Maximum of D14 means we are referring D14 to D19, so range is perfect, minus D14 means this value is perfect, and maximum of D14 means again this range, and so and so. We can again drag it further, but since the color will change as per the formatting of Excel, we'll write one more time the same formula. But now we are having the benefit criteria, so definitely the formula will change. So what is the formula for the benefit criteria? In benefit criteria, each value will subtract the minimum value of the respective column, and the denominator will same, maximum of each value minus minimum of each value. So let us do it here, that each value means this is the value. So let us start with the bracket, each value minus minimum of this thing. Since we are going to drag it horizontally, press F4 twice. The numerator is complete, then divided by, now the denominator is Denominator is that maximum value minus the minimum value. So maximum of this value, since we need to drag it horizontally as well as vertically, press F4 twice, minus minimum of these two values, again 2 times F4 to freeze the thing. So the formula is ready. So 3 is the minimum value and 3 minus 3 becomes 0. So why this value will be equals to 0. So drag it here further. So we are done with this. So this is the value, means each value, that is 8 minus the minimum of this, means 8 minus 3 is 5, and denominator is maximum minus minimum, so 8 minus 3 is 5, so 5 upon 5 will be equals to 1. So just like that we are having all the criterias. If you will notice that every criteria will be having 1, not necessary that every criteria should have 0, but here we are getting 0. So the first step is over, that we have normalized the matrix. So if you have seen or if you remember this algorithm, then the step 1 was the decision matrix, having the decision matrix. Step 2 was the normalization of decision matrix. So we have done. Now what we are going to do, we are going to calculate the deviation sequence. Now in the deviation sequence, what we are going to do, we are going to subtract each value from the normalization matrix from maximum value of the same column. Means what? If we are going to calculate the deviation maximum value, since we need to drag it horizontally, maximum value minus each value means each cell value. So just press enter. Now we will be having this value, and again drag it horizontally, we'll be having this value. Again same function is to be written here, maximum value from each cell value from this criteria minus each value. Now drag it horizontally and drag it vertically. So the deviation sequence is ready. Here you won't find a weight matrix, because here we are not considering that every criteria will have the uniform weight or are having different weights. Rather, the weight of criteria shall not influence the selection of the alternative. This was the main motto of Gray relational analysis. So why we have abolished, or the researcher have abolished, the weight matrices to be used in this particular method. So we will not be having the weight matrix. Instead of that, what we have done after doing the normalization, we have calculated the deviation sequence. Deviation sequence means how the values or alternatives are deviating from the ideal value. So we have got that. Now what we are going to do, we are going to calculate the Gray relational coefficient, GRA reduction coefficient. Now how that is to be calculated? Now if you means have seen the formula, it is the maximum value plus minimum value summation of the maximum value and current value plus summation of maximum values. So let us do it here, how we are going to use that. This is the value where we are going to multiply it by the maximum value. Now this is a value which is 0.5 in this formula. So how we can use that, let us see it here. It should be a it is a tricky formula rather. Minimum from each column, so minimum from each column. Now since we want to drag it horizontally, we will freeze it. Minimum from each cell, freeze it, F4 twice, then plus another bracket 0.5 into maximum of the respective column. Again freeze it by pressing F4 twice, since we want to drag it horizontally. So this is the numerator which is ready with us, divided by the denominator. Now the value plus 0.5 into maximum of this cell, since we need to drag it further. So this is how the formula is done. Means let us go to the actual thing. Minimum value, this the first thing, plus sigma into maximum value. The sigma is the probability that we are going to consider that it may appear, so that is 0.5. so why we have used that 0.5 upon current value, means the present value which is there into the cell, plus 0.5 into the maximum value, the sigma into the maximum value. So we have done exactly the same thing. The minimum value is computed in this way, plus 0.5 into maximum value divided by the current value plus 0.5 into the maximum value. Just press enter, drag it horizontally, drag it vertically. In any cell you could find the formula, means, and you just need to check whether it is okay or not. Whenever you will see the formula, you will come to know that how it is written. Earlier also we have shared you one trick how you can change the Excel sheet into the formula view and the data view. If you press Control and the button which is very next, or very the button which is below the escape button of your keyboard, that is the tilt operator. If you press these two buttons together, then your data view change to formula view, and again if you press it one time, the formula view get changed into the data view. So by changing it into the formula view, you will come to know that what is the formula which is applied in each cell. Excel will automatically give it to you. Again by pressing Control tilt operator, you will be into a position wherein you will be getting the data view. So now the things are over. We might have drag it further, but since the color will change, so what we will do, we will copy this formula, as we are masters in copying and pasting the things. So we have copied the thing, we came here and we have pasted it. Okay, now what we need to do, we need to change this P to Q, because we want to refer this particular column. So let us make it Q everywhere. Q, Q. Okay, so if you will refer this formula, minimum of the cell, whenever you double click onto the formula, it will give you that which column you are referring and which value you are referring presently. So the two values are referred. The blue color will indicate that this range is selected, and this light red rectangle in red color will indicate that you are dealing with the current minimum value. So just press enter, and now you just drag it horizontally and drag it vertically. You will be ready with your gray reduction coefficient matrix. So starting with the decision matrix, converting into the normalization matrix. Here the normalization was a linear normalization, not the vector normalization method. The only difference is that we might have used a different way to normalize the thing. Then the deviation sequence, how they are deviating from the ideal solution, and then getting the gray relational GRA reduction coefficient, and now calculating the CRG, coefficient of gray relational. How that can be done? It's very simple. It's getting the average of all the values present over here. average of all values, then press enter, then double click or just drag it down. So here we are getting the CRG values. Now this method is not using the weight value, wherein the concept was that every alternative have their own influence into the every criteria will have their own influence while selection of the alternative. So why the professor Zeng has proposed that there should not be the weight criteria. Instead we should calculate the deviation sequence, which gives us the deviation from the ideal solution. So this is how the method is. Now the simple thing which remains is ranking the alternative. So we just rank the alternative, select this rank and the entire range, freeze it because we want to drag it down. So just press F4 once and now you are ready with your solution. So this is the solution which is proposed by the GRA method. So this is how the GRA relational algorithm or GRA algorithm is used in MCDM technique. The major differentiation by using the GRA is that we are abolishing the weight, we are finding out the GRA relational coefficient, which gives you the approximity of the solution of selection of alternative, which should be the closer one to the ideal solution. So this is how the GRA algorithm works. So if you have any questions, then do put it onto our WhatsApp group and do raise your query so that we could answer. If I want to share you one paper with GRA relational approach and academic performance of Turkish universities. This is a simple paper, means the authors have used this GRA relational analysis while selection of universities. So what they have done, they have mentioned the GRA relational analysis, how they are processing the data, they have mentioned here, then how the GRA relational coefficient and GRA relational grade is calculated, they have mentioned here. Now performance indicator of universities, so they have calculated, or they means going through the literature review, they have fixed out some alternatives and the criterias also. So they have done it for 10 different universities and they have considered this in all 5 parameters. Means the 5 parameters they have considered is the article score, total citation score, total scientific document score, PhD student score and lecturer student score. So these are the 5 criteria they have considered to rank the universities. We have different ranking parameters, like in India we have NRF is there, NAC is there. So in fact, means if you will go through the NRIF ranking, you will find that the ranking is done by using this MCDM technique only. That is the weighted ranking method. In the weighted ranking method, you know that 5 parameters are there, student outreach parameter is there, or the institutional parameter is there. Every parameter is having their own weight, and by using that weight calculation method, they have ranked the universities. So they have used this kind of technique only. But means of course not a GRA relational technique, because GRA relation technique doesn't deal with the weight, but the NRF ranking deals with the weight. Every parameter has assigned a particular weight. So in this paper, what they have done, they have listed out the 5 criteria as per their own literature review. They have signified 10 universities, and with respect to this 10 universities and this thing, they have normalized the value and they have reached to a conclusion. So GRA relational theory are into great application. If you are using this for writing the paper, highest chances are there that your paper might get selected. So you could apply this thing by writing the paper. So this is how the things are there. So thank you guys. If you have the queries, then please post it onto our WhatsApp group. Thank you very much.